Okay, here is example for the nonlinear system. This kind of problem where we have two species, okay, of population of two species. One is represented by variable x, another one represented by y. Okay, so in this case, we have the two species. In the absence of either species, they would grow. For example, the first term from the first equation here represent when y species are absent, so x managed to grow naturally. Okay, the same with the first term in the second equation, when y absent, so the population for y managed to grow naturally, okay, at natural rate. The second term here for the first equation, this is the same species, x and x compete with each other, maybe for food, for space, and so on. Okay, so it leads to a decline to the population. Okay, that's why we have negative sign here. For the second term, in the second equation, similar. Okay, y square means competition between the same species of y. Okay, it may lead to the decline of the species. That's why we have negative. And the last term here is due to the competition between species x and species y, okay, which leads to decline to the each species, okay, x here and also y. Okay, that's why in both equations we have the same term. Okay. In this question, find the equilibrium points of the above system. Okay, I hope no problem with the equilibrium point, with the type and stability of the equilibrium point, the finding the solution. Okay, so we go through this question as an example. The equilibrium point. Okay, so we take the right hand side of both equation as usual to answer question number 1. Okay, so I will need to factorize the right hand side of the first equation, make it equal 0. So I will have x multiplied with 50 minus 4x minus 3y equals 0. So from here we get two expressions. The first one is x equal to 0. The second one is 50 minus 4x minus 3y equals 0. So here we have x equal to 0. Okay, make sure you not using this x0 into the second expression. Okay, to get y, it's wrong. But you have to use this. You have to pair its y from the second equation. Okay, so now I take the second equation equal to 0. I will factorize, so I will have y 40 minus 2y minus 3x equals 0. So I will get y equals 0. And another expression is 40 minus 2y minus 3x equals 0. Okay, so if we have x from the first equation, we have to pair y from the second equation. Okay, so means here, I think we may have three equilibrium points, if I'm not mistaken. Let us see. So the first x here, we can pair with y equal to 0 to get the first equilibrium point. So the first equilibrium point is 0, 0. Okay, besides that, x equal to 0 also we can pair with the second expression from the second equation. So when x equal to 0, we substitute into this equation, we will have 40 minus 2y equal to 0. So we get the value for y. So y equal to 20. So that will be the second equilibrium point. So this is the second equilibrium point. X is 0, y is 20. Okay, so this pair with this, and this value pair with this. Okay, so now we also can pair from the first equation. We have this expression, means we can pair with this. Okay, and we also can pair this with this. Okay, so there will be four equilibrium points. So if I pair the 50 minus 4x minus 3y equal to 0, I pair it with y equal to 0, I will get the third equilibrium point. Okay, so y equal to 0, substitute in here, we have 50 minus 4x equals 0. So this will give the value for x equal to 50 over 4, so 25 over 2. So this is the third equilibrium point, the value for x here, the value for y here. So the third equilibrium point here is 25 over 2, y is 0. And then we can pair the first equation from the first equation and the second equation, okay, to get the fourth equilibrium point. Okay, so the equation from the first one is this. Okay, so we pair them, solve simultaneously. So 50 minus 4x minus 3y equal to 0. We pair with this from the second equation. So 40 minus 2y minus 3x equal to 0. Here we have to solve it simultaneously. Okay, so solve simultaneously. Okay, solve simultaneously, we get the x and y from these two equations. So for x is equal to 50 over 4 minus 3 over 4y. Okay, you can substitute, or maybe you can use calculator. Okay, this is solving simultaneously. Make sure you will get, I'm not sure, you can use calculator maybe to solve the simultaneous equation. This is doing manually. Okay, you'll get the fourth equilibrium point. Make sure you will get a number for x, a number for y, okay, to be written here.